Okay, this is a new unit called Stoichiometry, and it's all about using information about how much of a reactant you have to figure out how much product you should get, or vice versa. If I need so much product, how much reactant do I need? This gets to specifics, things that people can actually measure. Okay. All right, so here we have an example. We have a deli that's making a popular sandwich. It uses 3 slices of meat, a slice of cheese, and 2 slices of bread. And the question is, how many sandwiches can the deli shop make? So go ahead and see if you can figure that out. And once you do that, figure out how many slices of meat are needed. You can pause while you do that. Okay. Now you can probably do this in your head, but here's the given, right? 3 slices of meat, 1 slice of cheese, 2 slices of bread. We can actually, even though you didn't need to do this, you can write an equation just like a chemical equation. We took 2 bread and 3 meat and 1 cheese, and we made 1 sandwich, right? Or 2 bread, 3 meat, 1 cheese, and we made 1 sandwich that had 2 pieces of bread, 3 slices of meat, and 1 slice of cheese. Okay, so if we wanted to figure out how many sandwiches we can make, you probably just did this in your head. You took 248 and divided by 2. But you could do this with factor label. 248 pieces of bread. And what we know is 2 pieces of bread give me 1 sandwich. Just going back to factor label, as you recall, we start with our given, and we want to have the same units below on the second factor so that bread and bread will cancel out. Okay, so when we do that, we end up with 124 sandwiches, which I'm sure is what you ended up with. Okay, if I want to know how many slices of meat are needed, I could take the 248 pieces of bread, and what I know is for every 2 pieces of bread, I need 3 pieces of meat, so that would give me 372 pieces of meat. Okay, so as you can see, the sandwich recipe looks very similar to the water recipe. And the key thing here is we're using the coefficients to tell us what the ratio between these materials are. So I could read this equation to say 2 molecules of hydrogen plus 1 molecule of oxygen give me 2 molecules of water. But I could also call this 2 moles of hydrogen plus 1 mole of oxygen gives me 2 moles of water. And the key thing here when we do stoichiometry is it's all about this ratio of moles. That's the key in helping us figure out how much we're going to get or how much of an ingredient that we need. So the ratio of moles, let's say the ratio of moles of hydrogen required to the moles of water produced would be the same, 2 to 2, right? And I need half as much oxygen. So the key learning is chemical reactions are in count units of moles. The ratio between reactants and products are what's most important. That's called the molar ratios, 2 moles of hydrogen to 1 mole of oxygen, 1 mole of oxygen to 2 moles of water. And we can use those mole ratios to convert between components. So let's take a look at a real example. Hydrogen sulfide gas smells like rotten eggs, and it burns in air to produce sulfur dioxide and water. The question is how many moles of oxygen gas would be needed to completely burn 8 moles of hydrogen sulfide. So what you always must do is start with the balanced equation, because that's what gives you those coefficients that you're going to need, right? So this says I'm going to produce sulfur dioxide and water. So let's go ahead and balance. So I've got 1 sulfur, 2 hydrogen, 2 hydrogen. But I've got 2 oxygen here, and I've got 3 here. So I've got to double this to make it an even number. So I have 2 oxygen and 2 oxygen. I'm going to need 2 of those, right? And because I have 2 H2s, I'm going to need to double that. And I'll need to double this to get 2 sulfurs. And when I do that, now I have 2 times 2 is 4 oxygen plus 2 is 6, so I'm going to need to make this a 3 oxygen. Okay, so this is my balanced equation, and now I'm going to use that to figure out my quantities. Alright, so if I want to answer this question of 8 moles of hydrogen sulfide, how much oxygen do I need? I'm going to start with my given. Whoops. I'm going to start with my given, which is 8 moles of hydrogen sulfide 8.0 moles of hydrogen sulfide. And then I need the ratio of I always need the same units down here, so I'm going to put moles of hydrogen sulfide. And I'm trying to get to moles of oxygen. That's going to be moles of oxygen. And I get my mole numbers here right from the equation. So moles of hydrogen sulfide is 2. Moles of oxygen is 3. And my moles of hydrogen sulfide will cancel out. And I end up with 8 times 3 minus 2. So that's 4 times 3 is... I end up with 12 moles of oxygen. And I want 2 sig figs, which is what I have in my given. Alright, I can also ask the question, what if, how many moles of oxygen would be needed if I burn 12.4 moles of hydrogen sulfide? So if I have 12.4 moles of hydrogen sulfide, and I want to know how many moles of oxygen, what I know is 2 moles of hydrogen sulfide. It's going to require 3 moles of oxygen. Alright, so my moles of hydrogen sulfide will cancel out, and I end up with 12.4 divided by 2, which is 6.2 times 3, so that's going to be 18.6 moles of oxygen. Okay, here's another problem. This is in your packet, number 2, I believe. Propane burns in air, right? So if you remember, burns in air, try to write the balance equation, you can pause it. But burns in air means I add oxygen, right? And I form carbon dioxide and water, as I would in all combustion reactions, right? So let's see if we can balance it. 3 carbons. I have 8 hydrogens. I'm going to need 4 of those. And now all I need to do is balance the oxygen. So I have 6 plus 4 is 10, so I'm going to need 5 O2s. Okay? So that's the equation. So if I have 12 moles of CO2, you see, 12 moles CO2, and we want to know how many moles of propane were burned. So I'm going to need moles of CO2 down here, so this cancels, right? And I'm going to want moles of propane up here. So this is balanced, so this is a 1. Moles of CO2 is a 3. So I'm going to have 12 divided by 3 is 4 moles of propane. Okay, I can also answer some other questions about this. I can say how many moles of oxygen are required to produce 8.4 moles of carbon dioxide. Alright, so I'm going to start there with my given, which in this case is going to be 8.4 moles of CO2. Oops. CO2, and I need moles of CO2 down here so that this will cancel. So that's going to be 3 moles of CO2, and I want to know how many moles of oxygen. So that's going to be 5 moles of oxygen from this 5 here. Okay, if I do that, I'm going to get 8.4 times 5 equals, divided by 3 equals 14 moles of O2. And it's 2 sig figs, just like my given, right? Okay, I can also answer this question, which is how many moles of water are produced from 0.55 moles of propane. So I have, let me see, 0.55 moles of propane. And I want to know, I got to put moles of propane down here, so that will cancel. And I want to know how many moles of water are produced. So I want moles of water up here. And I want 4 moles of water to just 1 mole of propane. The 4 for the water came from here. And if I take that 4 times 0.55, that's 2.2 moles of oxygen. Pretty easy stuff. Okay, so go ahead and complete worksheet 1, and that'll give us a good start.